I will send the email. I will send the URL to you to the email list today. But just to show you that it is prepared for you, this is the operating system's course homepage where you have PDFs of the slides. So I will send it to you, but you may see that this is on my homepage, edu eopsy, and that's all. So you may try to access that if you have the internet access. But be sure that today it will be sent to the email list, that address. So last time we talked about introduction about operating system. We defined the operating system, what it is. So the operating system, just as a review, is defined by two roles played by the operating system. The first one is management of resources in time and space. And the second role is presentation of easier to use machine to the user. User understands as programmer, and to use means to program. Something which is easier to program. Perhaps you remember that we asked how to survive with the hardware, which is very modern one, but does not have an operating system. How to force it to make our instructions, our orders. And it turned out that this is not very easy to be satisfied somehow without the operating system. So it is so good that we have the operating system which enables us to use that hardware. And what is a resource? Anything which may be allocated. We talked about different abstractions, like for example file, like for example file system, process. Those abstractions, they do not exist without the context or outside of the context of the operating system. They are abstractions created by the operating system. The role of the operating system is, in general, to allocate resources to processes. So we have the processes, and everything other is our resources. We discussed three modes of execution of the computer system in general, not the operating system, but the computer system. It means operating system plus hardware. Batch mode, interactive mode, and real-time mode. And key aspects of each mode are, for the batch mode, that it tries to maximize utilization of the processor. So, processor is a precious resource, and time of the processor is allocated as efficient as it is possible. So, for example, any kind of switching, like in scheduling, context switching is reduced because context switch is only waste of time from the point of view of advancing our computations. And other mode was interactive mode, so the main goal of this mode was to satisfy the client, the user's client, to respond as soon as it is possible. Not necessarily be extremely efficient, because extreme efficiency maybe is invisible from the point of view of the user. From the point of view of the user, the time of reaction is visible. If it reacts fast, it means it is efficient. This is that way of understanding. And who knows whether this is not a good definition or at least description of features of efficient computer system. To react as soon as it is possible for requirements of user. And the third mode was real-time mode. That was the mode of computer system in which it does not have to be extremely fast. It should not have to be extremely slow, because that operating system must be on time. It must run with some expected its expected efficiency. Because in the real-time mode we have some constraints related to time, and that system first of all must fulfill those constraints. And usually the user of that system is not the human being, but some kind of technological process. For example, on some kind of pipe in factory. And we talked about history of operating systems. We mentioned Charles Babbage and Ada Lovelace. And we talked about 4 generations. The first generation was related to ENIAC and Mark I, 2 supercomputers. One is presented. It was heavy, tough, and it worked on digital numbers. It had registers with digital representation of data, not binary representation. Lack of software, programming via plugging and unplugging cables and using some kinds of relays. We mentioned also John von Neumann architecture, and the important aspects were related to binary usage of binary systems, existence of arithmetic units, something which is currently understood as ALU in processors, arithmetic logic unit, and that we have 3 streams of data, input, output, and control of data. That branches are possible, and program may modify itself during the execution. For us, it is obvious that the program may modify at least the data of itself. But think about that we started from previous computation on piece of paper. So the computation was one line after another, written, so modification of itself was not so obvious. In second generation, that was the generation of mainframes. We also mentioned that not only mainframes were existing, but also peripheral frames, those which were prepared to prepare data for input and prepare data for being analyzed by people, beings. During the third generation, we had the idea of multi-programming, the idea of time sharing. The first system with time sharing was CTSS. That was the era of batch processing and interactive processing. We mentioned important role of the multi-x operating system. We mentioned the success of the machine PTP-11, which was not the mainframe but mini computer, 20 times cheaper with small decrease in efficiency comparing to mainframes. We also mentioned the role of the Ken Thompson, one of multi-x creators, programmers, when he decided to create something which evolved into limited version of multi-x, which was called Unix, as opposed to multi-x, or single user. We mentioned that there are 2 brands of Unix systems, that we have the idea of POSIX as the standard of conformance of some system calls, for example, or some behavior, or some expectations related to operating system. Because POSIX is broad and it has internally many standards. But for example, for us what is important, that usually when we ask whether the system follows the expectations of POSIX standard, it means if the system calls are defined in the same way and behave in the same way as it is written in POSIX. For example, example of POSIX system calls are those system calls for operating on files, which are open, close, lseek, longseek, read and write. These are system calls which should be available if that system is expected to follow conformance with POSIX standard related to files. The fourth generation, that was the generation of microcomputers, that was the era of general purpose processors. There was first success of something which is called CPM, operating system predecessor of DOS. After that, the idea of DOS, the story about digital research, IBM and Bill Gates, and the story of success of Windows system, the story of first successes of Apple, and with first operating systems like Lisa and Apple Macintosh. One may expect that from that time Apple was always successful, which is not true. Apple was very close to disaster after some years, because Steve Jobs left the Apple, and in fact you may be surprised, but existence of Apple was supported by money from Microsoft, because they tried to keep artificial competition. That they are not the only vendor of operating system which dominates anything, because they didn't believe that there may be next success of Apple. So in a way, they have huge influence in creation of huge competition to Microsoft solutions from Apple. We mentioned also the sources, the roots of Linux as an operating system, that it was created, obviously you know, by Linus Torvalds, who was after operating system course on the Minix, very simple Unix created by Andrew Tannenbaum. We have different types of operating systems for mainframes, for servers, for multiprocessor machines, and very often they were really limited to that scope. But as for now, it is usually just so that even if somebody is trying to create a new operating system, it is usually in fact based on somehow Linux. Somehow. Yes. For example, it may be called Android. You know probably that Android is based on Linux kernel. There are some changes, of course, to this kernel prepared by Google, but still it is rather Linux internal. Just a review of computer architectures. So the most important part is processor, which you probably know. We have some registers which we may recognize in each processor. They should be there. One of them is program counter, PC, not as a personal computer, but program counter abbreviation. So this is the current address of the next instruction to be fetched and to be analyzed. Yes. We have the stack pointer, so the place which defines currently the stack of current process. We have something which is described as PSW, processor status word, which is a register of different flags. Those flags are about the results of the previous instruction. For example, whether the result was 0 or not, whether the result was negative or not, whether there was the result generates overflow, and computer science in general, as you may see, is based usually on many abbreviations which are only understandable for computer scientists, not for, let's say, normal people. Yes. So, for example, we have